wabarakatuh. We already studied linear equations or functions. Now we want to move to quadratic and other different types of special functions. So when we talk about quadratic functions, the first thing that we need to know is how to recognize quadratic equations. All right. So if you're given a very general example here, all right. So here we can have ax square plus bx plus c equals to 0. This is an example of quadratic equation in a general form such that a can't be 0, because if a is 0, then the whole term here will be 0, and then we're left with bx plus c equal to 0. And this means it becomes linear, isn't it? So that's why we have to put restriction saying that a can't be 0. Alright, so these are the example of quadratic equation. The first one is this, and the second one is this. As you can see, if we look at the first example here, the highest power for variable x here is 2. Okay, so quadratic shows you that the power for the variable must be 2. I mean the highest. Same goes to here, left and right. You can see the highest power is also 2. Now, how to solve a quadratic equations? What's the purpose of solving quadratic equation? It is because we want to find what's the value of x. Okay, so here, in order to solve it, we need to understand the concept of a zero product property. If you can see here, this is 0, this is 0, isn't it? If you bring, let's say, this one to the left, the whole thing here to the left, then it becomes 0, this side on the right hand side, isn't it? It's a 0 on the right hand side here. The left hand side, we can have two numbers multiply each other can give 0. So either one of these two numbers must be 0, isn't it? So if we have a here and b here, either a or either b must be 0, so that any number multiplied by 0 equal to 0. Alright, so that means in order to find x here, we can transform this into two numbers or two groups, and these two groups, if they multiply each other, it becomes 0, isn't it? Or both become 0. Alright, so in order to find x here, to solve for factoring by factorization, so we must make sure that the equation, alright, equal to 0 on the right hand side. On the left hand side, two numbers or two groups multiply each other must be equal to 0. But easier to understand this if we look at the example here. So we want to solve this quadratic function by factoring. So let's say I will look at this example. Y minus 3 multiplied by y plus 2 equals to minus 4. Okay, let me rewrite it again here. Y minus 3 in bracket multiplied by y plus 2 equivalent to minus 4. So what we should do, we have left hand side here equals to right hand side. Obviously, you can see the right hand side here is not equivalent to 0. And also, if you see the left hand side here, you can't see this function as a quadratic function because you can only see y to the power of 1. But what if the left hand side here, we expand it? When we expand it, it becomes this. Y times y squared, plus 2y minus 3y minus 6, isn't it? Equals to minus 4. Now, clearly you can see y squared here. And then we want to make right hand side become 0. So we bring minus 4 to the left hand side. It becomes y squared plus 2y minus 3y minus 6. Bring minus 4 to the left hand side. It becomes plus 4 equals to 0. So you simplify further the left hand side. And then you can get y squared minus y minus 2 equals to 0. I hope from this line to this line, you know how to get the answer on the left hand side. So once we have this, you can see clearly we have transformed the original function here by expanding it and bring right hand side to the left hand side to get quadratic function and equate it to 0. Now from here, once we equate it to 0, like I said, when we have left hand side equivalent to right hand side, in order to get 0 on the right hand side, left hand side here, you may have a multiplied by b, either a equal to 0 or b equal to 0 or both. Okay, so in this case, in order to do this, but as you can see here, the quadratic equation that we have here is not in terms of a times b equals to 0. It's y squared minus y minus 2. It's all deduction. So we may need to factorize the left hand side here. When we factorize, I'm sure you know what it is. You have y minus 2 1, isn't it? So you can have, this is trial and error from here. Then factorization leads to y minus 2 times y plus 1 equivalent to 0. So this could be considered as a, this could be considered as b, a times b equal to 0, either this or this equal to 0 to get the right hand side equal to 0. So we have y minus 2 equal to 0 or y plus 1 equal to 0. This one y equal to 2 or y equal to minus 1. So we have this answer. But then if you want to make sure that these two answers are correct or not, then you substitute it back into the original equation here. Okay, to check whether it is equivalent to minus 4 or not. Okay, so why don't you try at home this function? You need to cross multiply, and then you can see there will be x squared here, and then you try factorize the function to get to find what is x. Okay, so this is one example of how to do factorization. There is another way to do factorization here. I'm sure you know the quadratic formula. So if x squared is equivalent to a constant, let's say x squared equivalent to any number of constant, let's say 4, then you know that x is square root of 4 equivalent to plus minus 2. Okay, so this is the quadratic formula, but this is very easy because the right hand side here you only have a constant. But what if you want to solve for this one? Okay, using quadratic formula, then the formula to find x is very straightforward. I'm sure you have seen this formula in the high school. It is minus b plus minus square root of b squared minus 4ac over 2a. Okay, now let me erase this rectangle first. Okay, when we try to solve this quadratic equation using this formula, you can see here minus b plus minus this bit. So this bit here, square root of b squared minus 4ac. Alright, the one inside here, which is b squared minus 4ac, if it is positive, then it's easy to square root it, because square root of positive, you can always find the answer, isn't it? I'm sorry. But then if it is 0, then that means this bit is, you don't have to worry about this bit, you only have this bit to answer, isn't it? But if the one inside here, which is this, is less than 0, then you can't square root it, then you cannot find the real solution, isn't it? Because when you square root any negative value, when it is less than 0, alright, then you can't find the answer. So you can't solve the whole thing here. You can't solve x as a consequence. Okay, now let's look at an example in which we want to apply this quadratic formula. Alright, so let's look at this. Okay, so let's say we have Social Security Trust Fund. The function is given by this. Okay, and then describe the Social Security Trust Fund balance B in billion of dollars, where T is the number of years past the year 2000. Okay, for planning purpose, it's important to know when the trust fund balance will be 0. So the trust fund balance is equivalent to this. Sometimes there's an occasion in which trust fund equivalent to 0, all right? Because we need to know if it is 0, then we can't distribute the money to the pensioners. All right, so we need to know when is the time it will be 0 so that we are prepared. Okay, so we equate it to 0, then you can see this one. you can factorize it, and because this is a very difficult way to factorize using trial and error, so we may need to use this formula to find t. Okay, so x in this question is actually t. All right, so here to find t, we need to recognize what is a, what is b, and what is c. In this case, okay, because ax squared plus bx plus c equal to 0. So this is the generic formula. So x squared, t squared. So a here is minus 1.057. Okay. Bx is this bit. So b here is 8.259. C is what? C is this one, a constant, 74.071. So if you want to find t, we know that the formula given is this one. So how do we find it? Okay, now here, t is therefore, you have minus 8.259 plus minus, okay, square root 8 minus 8.259 square, okay, because I don't have enough space, then I write it over here, minus 4, still square root, yeah, minus 1.057, okay, multiply by 74.071. Okay, so the whole thing here I continue here, yeah. So this one is continued here, okay, and then the whole thing here divided by 2a. In this case, 2 times a is minus 1.057. Okay, so if I write it properly, because you may not be able to understand because it's very messy, let me rewrite it again here. So your t basically should look like this. Okay, t equivalent to minus 8.259 plus minus square root, okay, minus 8.259 square, okay, minus 4, a is minus 1.057, isn't it? And then multiply by c, which is 74.071, close bracket, the whole thing here divided by 2 times a, which is 74.071. Okay, you see plus minus here, so that means you have to answer. Okay, the first answer is with minus, the second answer with plus. The first answer with minus, okay, you can see clearly here, the minus 8, so this is the first t, I call it t1, minus 8.259 minus square root of everything here, I write it as dot here because it's too long to write, and then divided by 2 times 74.071. I write it as dot because I don't have enough space, but in the exam you can't write this as dot, yeah, this one. Okay, don't write it as dot because I don't have enough space here. My main point here is that if you see the first answer with minus, I pick minus. Minus means minus here, and then minus again, you're going to get minus t. Minus something something, isn't it? And you refer back to the question, t is time. Time can't be negative. Do you get me? The question is asking you about what time that the balance will be 0. All right. Because t is time and time can be 0. So this one cannot be used as an answer. So that means what? You need to find t equivalent to using the plus one here. So minus 8.259 plus square root of this dot, because I don't have enough space, 274.71. Okay, and then when you calculate the answer, you're going to get answer, roughly speaking, equivalent to 13.145. So it means in 13.145 years, then the balance becomes 0. So you can see clearly the answer here is positive, so it makes sense. So with application question, you have to specify that the first T here can't be used as an answer because it gives you negative value of time. So you have to write down, and here I don't write down the justification. Then you have to use the second type of T in which you use the plus one, the plus sign here. Okay, so I hope this is very clear. Let's continue with another different example, which is this one. Let's say we have minus 7x squared plus 16x minus 4 equals to 0. Alright, so we want to put it in the form of graph as in figure 2.1 and also 2.1a and also 2.1b. Yeah, so the graph here shows that when, let's look at the first one here, yeah. When y is 0, that means we're looking at this, vertical axis. Then x is 2, for instance. Okay, when y is 0, then x is 2. Okay, alright. This is the first answer. Another answer is 0.2857. So when x is 2 here, and then x is 0.2857 is here. How do we get these two answers when y is 0? Again, we use this formula to find it. Remember? Okay. So if you see here, alright, so you have two answers here. It has two graphs because it just show you two different x, but actually we can combine it into one graph like what I did just now. Okay, so here when y is 0, because y is equivalent to fx, then it gives a solution to two x values. Those are x equivalent to 2 and x equivalent to 2 over 7 or 0.2857. Alright, so we can have these two graphs. Alright, now another thing about this quadratic function is that when we draw in the form of graph, as you can see clearly here, it is what we call parabola. Okay, the graph here is what we call parabola. Now, to study about it specifically, I mean the characters of parabola. So in general, we know that quadratic function has the form of this, in which y as a function of x, or y depends on x, which is equivalent to ax squared plus bx plus c. And we know that a, b, c here are the real numbers, not variables, and a here can't be 0. Why? Because a, if a is 0, not 5, not 6, not 7, then a multiplied by x squared becomes 0, isn't it? So then it wouldn't be quadratic function, it will be linear function, isn't it? Okay, let me erase this mess first. Okay, now, how do we graph a quadratic function? For the time being, this is the way we graph it, but once you learn derivative, there is a more formal way to graph this quadratic function. So let's say this we are using this general function of quadratic function, and the shape should be parabola, yeah. And then let's say we have a specific function here, y equivalent to x squared. So it is very obvious it is a quadratic function because, as you can see, variable x here, the highest power or the highest value of exponent is 2. Okay, we can also have another different quadratic function, that is this, y equivalent to minus 1/2 x squared. Okay, now if we talk about the first one, in which y equivalent to x squared here, y equivalent to x squared here can be graphed, and it is in A. So as you can see here, it is U-shaped, and then it has minimum point here, and this minimum point here is 0, 0, because when x is 0, y is also 0. So as you can see here, minimum point is here. On the other hand, if we have y equivalent to minus 1/2 x squared here, then it is depicted in graph B, in which you can see when x is 0, y is also 0, isn't it? And then it gives you maximum point. Okay, because the maximum point and minimum point for B and A respectively happens at coordinate of 0 and 0. So basically here the graph here is symmetry at point 0, 0. So what I mean by symmetry here, if we have a graph like this, the vertical line here divide the graph into two segments, segment 1 and segment 2. As you can see, segment 1, if you flip it to the right side, it will be equivalent to segment 2 in terms of size. So basically, the vertical axis here is symmetry between the two areas, I mean area 1 and area 2. Now, another term that I want to introduce to you here is that at this symmetry line, we can see that this is the minimum point, okay, which is similar to the graph in A. And if we have graph B, we also have vertical line here at this maximum point, okay? And this minimum and maximum point here, another term to call them is vertex. So basically what is vertex here? Vertex here is a point in which you can see clearly a curve changes its direction. For instance, for the first graph here, before minimum point, before the vertex here, specifically minimum point, you can see the graph is downsloping. The curve itself is downsloping. Nevertheless, after the vertex point at minimum here, then you can see it changes its direction. It's becoming upsloping, similarly to this one, but the opposite way of explaining it. So vertex here can show you that there is a change in the direction of a curve. Okay, now let's be specific about vertex of parabola. So here it is. So if let's say we are using this equation for our quadratic equation, it's obviously that it is a parabola. If you can recall back the drawing, it is a U shape open up, isn't it? Open up, which is this one. I'm referring to this one. U shape, it looks like a U, and then it is open up. Okay, open up because the upper area here is open, not closed. Okay, now it will be open up. How do we know that whether it is open up or open down here, or U shape or inverted U? The y equivalent to ax squared here, if the a value here, the constant or the scalar, is positive, alright, then it will be U shape. But if a value here, let's say minus 5, which is less than 0, negative value, then it becomes, inverted U. Okay? So, the vertex here where the parabola turns is therefore a minimum point if the value of a here, the constant here that attached to x squared, is positive. But then it becomes, minimum point, the vertex becomes minimum point if a value here is negative. Alright, so if I redraw again any kind of parabola graph, let's say like this, and then we know that the minimum point is here, then I draw a vertical line that passes through this minimum point. Okay, so like I told you earlier, area 1 is similar to area 2. If you flip it to the right side here, then the line here or the axis here is the axis of symmetry, because half of the graph on the left hand side is just the same size of the half of the graph of the right hand side here. Okay, so similarly, if you have the graph that look like this, you draw a symmetry line exists like this. One area is similar to this area. Alright, so the graph here, the other side is basically the reflection of the opposite side. Okay, reflection. Alright, now let's say we have another different quadratic function which is given by this equation. In particular, y equivalent to x minus 2 in bracket square minus 1. So if you have y equivalent to x minus 2 in bracket here square and then minus 1. So what happens here is that initially you have y equivalent to x squared, isn't it? Now you have this one. You can see the addition inside before square, the addition for x here is minus 2. And then after that, you have minus 1 after the square. So what does it mean here? Basically speaking, if you have x minus 2, then it shifts to a new location by 2 units, okay, to the right. Because initially, it was like this, okay, when we have this, okay. But then because you have x minus 2, then only you square. So from here, okay, the minimum point, the vertex move to x equivalent to, instead of x equivalent to 0, as you can see here, okay, x equivalent to 2. And then because we have minus 1 here shifts the curve downward by 1. You can see here from this, shift downward by 1. From this, shift to the right by 2 because of this. Shift downward by 1 because of this. Okay? Alright, clear? Alright, now, next. So, if we have graph like, a quadratic equation that looks like this, y equivalent to minus 1/2, in which in the bracket x plus 1 square, initially it was x squared, isn't it? And then plus 2, okay? Initially it was like this, isn't it? Where was it? This one. Okay, initially it looks like this, isn't it? But then inside here we have what? Addition x squared, alright? And then plus 1, and then you square it, and then plus 2. So you have this bit as the additional bit and this one. So that's why you can see clearly here, because you see minus sign here and you add this one inside here and it's attached to this minus 1/2, so it will shift to the left from original one here by 1 unit. So initially it was like this, isn't it? Okay, 0, and then it shifts to the left by 1. Okay, the vertex here shift to the left by 1, and then you can see it is added by 2, shift upward by 2. Okay, is it clear? And so how to calculate vertex value? Basically, how do you know that the new vertex value here is minus 1, 2? So there must be a formula to calculate the vertex value, isn't it? Alright, now if you have a generic function like this, the simple formula for vertex is this. So this is for the value of x of vertex, this is the value of y for the vertex. So in simpler form, you have x, you have fx. X is given by minus b over 2a, fx is given by function of minus b over 2a. That means if you get, let's say, x after you calculate minus b over 2a, you get, let's say, equivalent to 2 or equivalent to 4, for instance. Yeah? Then how to get y? 4, insert it back to this original function, calculate it. Let me erase that mess first. So you see x is equivalent to 4, insert it back into original function y. We know that y is fx, isn't it? Which is this one. Okay, equivalent to y. Then once you get x equivalent to 4, okay, then you insert it back into y or fx to get y. Okay, then you get something about y here. So as simple as that. However, there is many different ways to find it also later when we learn derivative. Okay, so when you have this or you have this, you have minimum here, here you have maximum. These two values of vertex, maximum or minimum, in general is what we call optimum value. Okay, specifically maximum if it looks like this, specifically minimum if it looks like this. But in general, if we say optimum, optimum values can be maximum or minimum. Okay, alright. So the optimum value is the maximum or minimum of the function occurs at x equivalent to this and y equivalent to f, to not minus b over 2a. This is a typo, yeah? So y equivalent to f, um, minus b over 2a. Okay, all right. So that's for vertex. Now, next, so let's say we have this. So you can see clearly here is that, again, we repeat, if your A is positive, then you're going to have minimum point as your vertex. But here you can see clearly if your A is negative, then you can have maximum point for your vertex. Okay? And then we know that the formula for x at the vertex point is minus b over 2a, and then y, you just insert that x into y formula or fx, then you can get what's the value of y. Now let's do the exercise. Let's say we have a specific function that is y equivalent to 2x squared minus 4x plus 4. So the question here is to find the vertex and also to sketch the graph itself, because we want to know whether it is minimum point or maximum point. Okay, let me rewrite again the equation here. So y equivalent to fx equivalent to 2x squared minus 4x plus 4. Okay, now let's find the vertex. We know that the vertex formula is basically, x and y, specifically with the formula minus b over 2a comma f minus b over 2a in it. Okay, so for this case, we need to recognize what is b, what is a, what is c. So a in this case is 2, b in this case, b in this case is minus 4, and c in this case is 4. So it makes our life easier when it comes to calculation. So now x is basically minus b minus 4 times minus, okay, over 2a over 2 times 2. Okay, alright. So I haven't solved for y. I try to solve for a first, then it becomes 4 over 4, and then y, it becomes 1, isn't it? Now you substitute this one back into this equation, original equation, because you need to get y, because y is this one, isn't it? Okay, so basically it becomes 2 times 1 square minus 4 times 1 plus 4, close the bracket. So it becomes what? 4 minus 4 plus 4 equal to 4. That's the answer for the vertex for this graph. But we also need to know whether it is maximum point or minimum point. It so happens that a that we have here, okay, a is equivalent to 2 greater than 0, then it gives us vertex here, minimum point. Okay, so the vertex here is minimum point. Okay, now, so we also need to put it in the form of graph, but when we put it in the form of graph, you have to understand, let's say x is here, y is here. We can have minimum point that looks like this. We can also have it here, we can also have it here, we can also have it here. So the next question is, which one is correct, isn't it? So for any curve here, we need to know whether it intersects the vertical axis and horizontal axis or not. Okay, that makes our life easy when it comes to drawing. So that means we need to find the intercept. Okay, so intercept here, let's say we want to find the vertical intercept. Vertical intercept is when we set x equivalent to 0. Remember when we learned linear equations last time? Okay, when we set x equivalent to 0, so our y becomes what? 2 times 0 square minus 4 times 0 plus 4. So our y becomes 4. So our vertical intercept here is 0, 4, isn't it? Okay, 0, 4. So we have vertex, we know that is minimum point. We also know vertical intercept. But do we have horizontal intercept or not? Okay, but here, if you see the drawing, okay, let's say I have this. So vertical intercept is 0, 4. Okay, vertex is minimum point. At what point just now? It is 1. Sorry, that's 1, 4. Okay. Alright. Then when we try to put it in, when we try to put it in the form of drawing, we draw the vertical axis and horizontal axis. Okay, 1. Because I see vertical intercept and also vertex here are positive, minimum point is in positive quadrant. X is positive, Y is positive. So I know that minimum point is in positive quadrant. So we can sketch it. Let's say 0. Let's say 4 is somewhere here. Let's say 1 is somewhere here. So minimum point is here. So I know that before minimum point, my curve will be downsloping like this, isn't it? Downsloping like this. And I know that after minimum point, it will be upsloping like this. Okay, so here I have something. Let me draw it properly here, because it was not smooth in one go. That's why it looks like this. Okay, then I know that it's gonna be right. Then my y equals to 2x squared minus 4x plus. Now you look at this point, it hits here. Logically speaking, when minimum point here, the value of y is 1, so you know that it hits vertical axis above 1, above minimum point, isn't it? And we did find the vertical axis here, the the intercept equivalent to 0, 4. Logically speaking, you are in the first quadrant. When you go up, it doesn't hit the horizontal axis. Can you see? Alright, so this is how we sketch a graph using current knowledge about quadratic function. But like I said, there is another different way to sketch a function if you learn derivative later. Okay? Alright, now, and here, let's move to the next one, which is a zero of quadratic function. When we say zeros of quadratic function, zeros here refers to what? Zeros here refers to the value of y equivalent to 0. Then when the y equivalent to 0, then what is x? Okay? Now, zeros of quadratic function, the x-intercept of, in this case, because we have y and x is on the vertical axis, okay? On the horizontal axis. Therefore, the horizontal intercept here is also known as x-intercept because we use x as our value for, horizontal axis. All right. The x-intercepts or the horizontal intercept of the graph function of y equivalent to fx is actually the value of x for which y equals to 0 or fx equal to 0. That's why it's called the zeros of the functions. So the zeros of the quadratic function are like this. If you want to find the value of x, you already know the quadratic formula. So this is how we find it, isn't it? Okay. Let's summarize all the things that we have learned for the graph of quadratic function. Okay. So the first thing, let's say you are given a general function of quadratic, which is given by y, equivalent to ax squared plus bx plus c. We know that this quadratic function means parabola curve. Okay, so we need to know whether it is upside down U or U shape, inverted U. This one is what we call inverted U. This one is what we call U shape. We can
determine either one of these if we know the value of A. If A is positive, then the parabola is opens upward, which means U shape. So we have the minimum point as our vertex. On the other hand, if A is negative value, then parabola opens downward like this. It is inverted U, then the vertex is specifically maximum point. The vertex maximum and minimum in general, like I said, called optimum values. So the coordinates of vertex given by these two, okay, x equivalent to minus b over 2a and y given by function of x, okay. Axis of symmetry equation is equivalent to this. Axis of symmetry, if let's say you have this, then the value of x here is this, isn't it? Which is this. Okay. Alright. So for here, let's click on. Let's go back to the zeros of quadratic function. We know that the zeros of quadratic function here can be found using quadratic formula like this. X positive, x minus. You can have two x values to answer y equivalent to a 0. So all of this you have learned previously. Yeah? And the zeros of quadratic function is actually the horizontal intercept or the x-intercept, as you can see here. So here the first one is 0, 0 and another something 0. This one is 0, 0. This one is some value of x and y equivalent to 0. Okay. This one 0, 0 and some value of x which is negative and y is 0. Here value of x here is positive at this point, but y is 0. Here value of x here is negative, but y is 0. So you can see 2 points here that gives you zeros, values of quadratic function. Let me erase this so that it doesn't look like a mess. Okay. So if let's say you have this function y equivalent to 4x minus x squared, okay, if the question asks you determine whether its vertex is a maximum point or a minimum point, and find the coordinates of this point, find the zeros if any exist, and sketch the graph. So we're going to do this in a bit. Let's talk about the average rate of change. You learned in the linear function previously that when we talk about rate of change, it's also equivalent to slope. Okay, so slope of a linear function, for instance, or rate of linear functions. The linear function, when you calculate slope, the slope is always the same along the line. So for instance, if I have this, let's say I have W here and Z here, and then have line something like this. And then let's say I'll calculate the slope here, which is M, okay, or slope, equivalent to 5, positive 5, because it's upsloping, yeah? So that means from point A to point B, the slope or the rate of change is 5. Similarly, from point B to point C, the slope is also 5. That means if I want to increase from point W1 to W2 here, from A to B, then every time I increase 1 W, then Z will increase by 5 from A to B. Similarly, from W2 here to W3, from point B to C, when I increase 1 W from W2 to W3, then my Z will also increase by 5. Okay, so from A to B, B to C, the rate of change or the rate of increase here is just 5. Okay, that's for linear. However, we know that the nonlinear function, when you have nonlinear, from point A to point B, okay, and then from point B to point C, they may have different rate of change because it's not the same. When the rate of change is not the same, the slope or the rate of change is not constant, isn't it? So how do we know about the rate or the increase here, how much it will increase and whatnot? For the time being, you can learn what we call the average rate of change, the average slope on average, yeah, because we have nonlinear. On average, what's the change from one point to another point, even if it is not smooth. When I say smooth, it's linear like this. When I say not smooth, it's not linear like this, yeah, because from point A to point B, it's very obvious that you have different slope compared to from point B to point C. Another way to look at whether the slope is not the same or not. Let's say I have the curve. Okay, I pick one point here and I draw a line that tangent. It's not intersect, yeah, tangent. This is what we call tangent. One point on the straight line and another point on this original curve. They meet each other. Another point here and I have another line, tangent line. So you can see the first tangent line compared to the second tangent line. The first one is steeper compared to the second one. So that gives you some idea is that the second one is flatter. So the second one must have, you know, a smaller slope than the first one. So in this case, from point here A to C, C to B, they don't have the same slope. Therefore, because they don't have the same uniform slope or the same slope here, the slope is not constant. So, and one way to see the change here or the rate of change here is by taking an average. Okay, so the average rate of change is basically, let's say we have 2 points. The first point is here. We call it point A for the horizontal value x and FA for the vertical value of fx or y. Let's say this is y equivalent to fx. So the average rate of change here, you need to have another point so that you can find the change. Okay, so another point here is this one, point B here and then FB here. Okay, so you have these 2 points and then you join these 2 points. As you can see, we have the red line, the straight line that gives the join of these 2 points. Okay, and then we can calculate the slope of this straight line instead of the slope of this curvy line, the black one. Okay, so how to calculate the slope of red line here is just the same as the way you calculate any other slope that you have learned before. So you have here, because you have 2 points, so the first point is A and FA, isn't it? The second point here is B and FB. So this one considered as Y, this one considered as X. So M here is basically, of course, Y1 minus Y0. In this case, FB minus FA divided by B minus A. And the red line here, because it connects the 2 points along the original curvy curve, which is black one, this line is also known as second line. Okay, second line. Okay, now let's look at an example here. But before that, I just want to emphasize more. You look at the word average here. This line is what we call ratio, isn't it? So this is the difference on the vertical axis. This is the difference on the horizontal axis, isn't it? So this one is B minus A. This one from here to here is FB minus FA, isn't it? So the difference on numerator is the difference on the vertical, axis values. The difference on the denominator is the difference on the horizontal axis value. You have these two differences. You take you divide by 2. The moment we say we divide means average. Okay, divides means average. But you look at the formula here, it's just the same like the way you calculate change in Y over change in B, isn't it? Alright, but it's average. Why we call it average? Because it's not for every point, because not all points along the black line are the same. So we just take the average. Okay, now let's look at the example. Okay, we have example 6 from textbook here, the average rate of change of revenue. So the revenue of the cruise is defined by the following quadratic function. So let's say we have a cruise, so it gets many customers passengers. So it calculates its revenue, and the behavior of its revenue looks like this quadratic function. What is x? X is the increase in the group size beyond 50. So let's say on average group size is 50. So if it is beyond 50, then that x shows you the amount of increase. Okay. What is the average rate of change of revenue if the group increases from 50 to 55? So the idea here is that if you want to talk about x, initial group is 50. Therefore, there is no change, isn't it? But if group increases from 50 to 55, then there is an increase from 50 to 55, from 0 value of x to 5 value of x. 5 here refers to the increase in group number, group size. Is it clear? So don't be confused with 50 and 55. Actually, the x value here is these two. Okay, so be careful when you read. So if that is the case, so we have x0 and then x5. So we want to calculate the average rate of change of revenue if the group increases from 50 to 55 persons. So we need to find the average rate of change in revenue. All right. So because we have the first x0, the second x is 5, then we need to find the revenue for each of them. Then we can find the average rate of change for revenue. So this is x1 equal to 0, x2 equal to 5. So y1 is what? In this case, y1 is r, x1, isn't it? y2 is what? Is r, x2, isn't it? Then you calculate. So because you have x1 equal to 0, you just need to substitute back into revenue function. So you have 1,500 plus 50 times 0 minus 0.5 times 0 square. Then you get the answer equals to 1,500, isn't it? What about y2? Y2 here is, okay, if I rewrite it here, 1,500 plus 5 times 5 minus 0.5 times 5 square. So what do you get here? When you calculate it, you're gonna get 1512.5. So here, class, for the first x, you have y1, which is 1,500. For the second x here, you have 1,512.5. So here we have two coordinates. Coordinate number 1, 0, 1,500. Coordinate number 2, 0. Sorry, not 0, yeah? 5 is actually 5. Okay? 5, 1,512.5. So you have 2 points. So this is x, this is your y. You can calculate the average rate of change. Okay, now let me use the same space, but erase it somewhere here. Let me calculate it here. Therefore, the average rate of change is what? Let's call it m. Let's call it m. Is equivalent to the new y minus the initial y divided by the new x minus the initial x. So here 1512.5 minus 1500 and 5 minus 0. So when you simplify it, it's equivalent to 12.5. Okay, so this is basically the answer. All right. Wait a minute, it's wrong. The calculation is wrong. This is not 12.5, but it is 2.5. Okay, now we have this 2.5 as the average rate of change. So that means if revenue increases by one, let's say $1. If the group size increases by $1, revenue will increase 1%. The revenue will increase by $2.5. How do you know increase? Because it's positive sign. Okay, the difference is positive. Okay, so this is how we do it. And if it is in the form of graph, let me erase this here. because I just want to show you in the form of graph to visualize it. Remember, the revenue function that we have here is a quadratic function. If it is quadratic function, then usually we want to have more revenue. Maximum is better, isn't it? So as you can see here, if you see A is minus 0.5. How do you know A is minus 0.5? Because x squared is here. B here is positive 5. And then C here is 1,500. Since A is minus 0.5, which is less than 0, so we know that the vertex of revenue is maximum point. So if we put it in the form of graph, so we have x here, we have revenue x here. Then when we draw, okay, you can see here the first coordinate is 0, 1,500. So 0, 1,500 is actually the vertical intercept, which we already found here, yeah. Okay, and then we have vertex here. The vertex, we have the vertex here. If you see the vertex formula, it is what? Let's say, b minus b over 2a. Okay, minus b over 2a is for the x value of vertex. In this case, minus b is what? Minus 5. 2a is what? 2 times minus 0.5, which is equivalent to positive 5. So when x is positive 5, you actually have it here. Okay, this one. You already found the y itself. Okay, the y is this one. So here, the y is positive. Do you get what I'm talking about? Because x for vertex, using this formula, give you 5. And if you recognize and you realize, we have found, the vertex value, which means x, which refers to x2 here from the question itself. So x2 has been found, and therefore y2 also being found. So actually this x2, y2 is actually the vertex for this function, isn't it? And we know that since a is negative value, minus value, then this vertex is at the maximum point. So it may looks like this. So this is the vertex. So here is 5. So here is the value is 1512.5. So the coordinate here is 51512.5. So that's how it looks like. But because the question is asking you about the average rate of change, so the average rate of change, if you refer back to this one, it is the calculation of the slope of the second line. The second line is actually the straight line that joins the 2 points, the first point here and the second point here. Okay, so the second line here, when you get the slope equivalent to 2.5, is actually the change in Rx here and the change in x, which is this, the change in Rx over the change in x, isn't it? The change in Rx is this one, the new Rx, which is y2, minus the initial Rx, which is y1, which is this one. The change in x is this one, isn't it? Which is this one. So the average rate of change in this case is the slope of the second line, which we have found here. Is it clear? So that's how you visualize it. Okay, now let's look at the application of in business on quadratic function. One good example is the break-even points and also maximization. Okay, the break-even points. So when we talk about the break-even points in a business, we have costs. Because we need to produce output, we have to buy input, so we have costs. Okay, let's say that cost is depending on the quantity of output produced, which is x. So C depends on x, cost. But then after that, after we produce, we want to sell it. Once we sell it, we get the revenue. The revenue here depends on how many quantity of product we can sell. In this case, R depends on X, as X is the quantity you can sell. Alright. The break-even point is a situation in which cost equivalent to revenue. That means because calculation of profit Px, this is Greek letter P or pi, you may pronounce it. Pi x or Px is actually equivalent to revenue minus cost, isn't it? So when it is break even, revenue equals to cost, that means you have zero profit. Okay, so in a monopoly market, for instance, for any company, the revenue of a company is restricted by the demand of the product. In this case, okay, the relationship between price of the product and the number of units sold, which is X, is described by the demand function. Okay, P depends on X, price depends on quantity sold. Okay, and total revenue function is therefore price times quantity. This one is price, remember this one, and then quantity X. Okay, let's look at the first example here, break even point. Okay, now suppose that in a monopoly firm, the total cost per week of producing a high-tech product is given by this. Okay, and you can see the cost function here is quadratic, because if you look here, all right, the highest value of power here is square for variable X, quantity of product produced and so. Okay, suppose further that the weekly demand function for this product is P equivalent to 500 minus 2X. The question here is that, so you can see a P as a function of X. Remember this? Okay. Find the number of units. So find what is X that will give break-even point for the product, that will give profit here equivalent to 0, in which cost equivalent to revenue. So find what is quantity here. Alright. So how are we going to find it? Here you are given cost function and then price function. But you know that break-even is cost equivalent to revenue function instead of cost equivalent to price, isn't it? So here, with price function, you need to use it to find revenue function. So first, let me rewrite again all the equation here, yeah? So we have cost function equivalent to 3,600 plus 100x plus 2x squared. And then we have price function equivalent to 500 minus 2x. So first, like I said, we need to find revenue function. Revenue function here is price times quantity, isn't it? In this case, price, substitute here, times quantity. So it's equivalent to 500x minus 2x squared. So this is our revenue function. So next, we need to find X at break-even point. We know that break-even condition is what? When cost is equivalent to revenue. So we have cost function, which is here. We have revenue function, which is here. We substitute it back into this break-even condition. So 3,600 plus 100x plus 2x squared equals to 500 minus 2x squared. Now, you rearrange it. So here you have 3,600 minus 500, bring 500 to the left. And then you have plus 100x plus 2x squared. And then you bring this minus 2x squared here, becomes plus 2x squared. Then the whole right hand side becomes 0, isn't it? When you solve it, then you get, what is it? You get this one, 4x squared plus 100x plus, what is it? So we have 3,600 minus, oh, I think I forgot x here. That's why it makes mistake. Sorry, yeah. also x. So here minus 500 plus 100, it becomes minus 100. Sorry about the mistakes. Let me erase it first. So here, so we have 3600 minus 400x plus 4x squared equals to 0. Okay. Now you can even simplify it further by factorizing it with a common factor. So you're going to get 4 inside here. Then you have 900, okay, minus 100x plus x squared equivalent to 0. Okay, you get me? So I move to the next page. Then I can simplify it further. 900, okay, minus 100x plus x squared equal to 0. Or I can rewrite it this way. X squared minus 100x plus 900 equals to 0. Alright, remember we need to find what is x, yeah, so that we know how many quantity that gives you break-even condition or profit equivalent to 0. So what we can do here is that you can factorize the left-hand side of of x squared minus 100x plus 900 equal to 0. So it becomes x minus 90. You can use trial and error to do this, which you have learned in the school. X minus 10 equivalent to 0. Okay? So for x minus 90 equal to 0, then it gives you x equivalent to 90. For x minus 10 equivalent to 0, then it gives you x equivalent to 10 here. So in this case, break-even quantity are 90 and also 10. Okay, 90. In the form of graph, because we have cost function and also revenue function, this is just to visualize so that you can see clearly what does it mean by break-even. Yeah, so you have x quantity sold, produced and sold, and then you have money terms here, let's say dollars. So if you can see here, the revenue and also cost. Revenue looks like this, and then you have cost. So this is cost function, this is revenue function. So you can see two intersection here in which C equal to R, isn't it? So the first one here is 10, the second one here is 90. So with 10, you get what value here? With 90, you get what value here? So with 10, actually, if you calculate it, put it back into C or R, okay, either one of them, either C or R, you're gonna get the the value of cost or revenue here equivalent to 4,800. So for this point, okay. So for here, you have 90 and also 28,800. Okay. How to get 28,800? You put it back into either one of the function, cost or revenue. You're going to get the same because at this point they are just the same. Okay. Alright. Now, let's look at the second example, profit maximization. For the same cost function and also revenue function from this example just now, previous example, find the number of units that maximizes profit and find the maximum profit. So you need to find what's the value of profit at maximum, and then you need to find how many quantity of x that leads to this maximum profit. That's the question, yeah? So basically what you need to do is from cost and revenue function, you need to create a profit function. Okay, so you know that profit function I write it P, or great letter pi, you may call it PX, equivalent to revenue minus cost, isn't it? So in this case, the revenue given from the question, okay, already we knew it, right? Already we found it. So the revenue here is basically 500x minus x squared, isn't it? And then minus the cost function. So the whole cost function here is 3600 plus 100x plus 2x squared in bracket. So when you simplify it, your profit function px, or pi x you may call it, becomes minus 3600, okay, plus 400x minus 4x. So in between here, there are some steps that you have to show. Yeah, here I just jump into the last step, but in the exam, in the schoolwork and whatnot, you need to show all of the steps here. How do you get minus 3600? How do you get 4 plus 400x? How do you get minus 4x squared? Okay. Now, because we want to find the value of x and also the value of profit when the profit is at maximum, so we need to find the vertex, because vertex is the point of minimum and maximum. For profit, nobody wants to have minimum point, isn't it? Nobody wants to get minimum profit. So obviously, for the vertex here, it is maximum. Furthermore, how do you know the vertex here is maximum? Because if you can see here, a from this function is minus 4, which is less than 0. So you know that the vertex has maximum point. Okay. So now find the vertex, because here you have, if you try to visualize it, you have x here, you have profit here. So your coordinate for vertex will have x and also px. Okay, so that's your vertex. Vertex maximum point is this one. So how do you find x? You know that the formula is minus b over 2a, and then that's for x. So then you substitute it back into p function, b over 2a, isn't it? So in this case, minus b, b here is 100, okay? This one. A is minus 4. So here minus, and then makes minus 4 over 2 times b. Sorry, it's wrong. I chose the wrong one. Okay. So minus b minus 100 times 2 times minus 4, which is a. So, and then here you have b minus 100 over 2 times minus 4. Okay. So, and then when you solve it later, you have some step. I don't have enough space here. Then solve it. So for profit, so for this you have to show all the work. Then you're gonna get the point here, which is 50 and also 6,400. 50 here is your x, 6,400 is your p, or profit. Great letter, yeah. Alright, now, so in order for you to maximize profit, you must produce and sell 50 quantity. So what is the value of maximum profit if you produce and sell 50? What you can do, 50 here, plug into this profit formula, show all the work, because here I just jumped the step, yeah. But in the exam, in the quiz, you must show all of the steps. Here I just jumped the step. When you substitute it back into x here in the profit function, you're going to get 6,400. 6,400 is the profit, therefore this one is in terms of dollar. The profit received by this, let's say, company or whatever, or firm, or factory, is $6,400. So this is the vertex, and that means it is maximum point. So you know that from previous exercise, okay, x is 90, x is 10 when it is break even. So you have 90, 0, and 10, 0, isn't it? Break even means, alright, the profit is 0. This profit is 0. Okay? So that means here we already found, you know, 1 here 10, 1 here 90, 2 points as a break even. So here we have these 2 points. I hope you understand how to get these 2 points. This is profit function, no longer cost and revenue function. How do I transform once again? How do I transform from here x equivalent to 90, x equivalent to 10 and get these two coordinates 90 and 0? Remember, at 10 here, okay, we have cost equivalent to revenue. Okay, at 90 here we have cost equivalent to revenue as well. Alright, when they are equivalent, the difference between cost and revenue is 0, and this formula is actually profit, isn't it? Equals to 0. So that's why I can easily get these two coordinates, okay, 90, 0, 10, 0 for my graph here. 0 for profit, because profit is on the vertical axis, x quantity is on the horizontal axis. That's why I get these 2 points. 10, 0, 90, 0. You get me? And we did find vertex just now. Our vertex is 50x and 6,400 profit. So let's say it's here. So 6,400 profit here. So we join these 3 points to get, you know, a parabola, but it is inverted U, in which we have 50, 6,400 as the vertex. So the profit, maximum profit is here, given by this vertex value. Is it clear? These two values are basically zeros of profit functions, isn't it? Which gives you quantity or x, 50, 10 and 90 respectively. Okay, so that's for profit maximization. Now we move to the next one here. This quadratic function can also be applied for supply, demand, and market equilibrium. Here, if you see the first graph of 2.14 here, this is inverted U graph, isn't it? But if you look at the first quadrant, the inverted U graph in the second bit here shows the downsloping. So this bit can show you the negative relationship between price and quantity demanded. Okay. On the other hand, if you have quadratic supply function, which looks like U, all right, you have two areas of graph Cartesian plane. But if you look in the first quadrant here, you can see this one upsloping. So this is the bit of supply function that you can use from the original quadratic function. So let's look at an example here. Okay, example 3, market equilibrium. If the demand function for a commodity is given by P times Q plus 4 in bracket equivalent to 400, and the supply function is given by 2P minus Q minus 38 equivalent to 0, find the market equilibrium. Okay, so here you have demand function, which is P times Q plus 4 equivalent to 400. Okay, and then you have supply function, which is 2P minus Q minus 38 equivalent to 0. Let's call this one number 1. Let's call this one number 2. Okay, I can rewrite number 2 as this. If I, P equivalent to, 2P equivalent to Q plus 38, isn't it? Then I can have P equivalent to 1 half Q plus 38 over 2, which gives you P equivalent to 1 half Q plus 19. So this is our supply function. Similarly with the demand function here, I can rewrite it this way. P equivalent to 400 divided by Q plus 4. Okay. plus A. Okay. Alright. So in equilibrium, we have equilibrium condition. Remember, we need to find the market equilibrium. Okay. Find what is price in equilibrium. Find what is quantity in equilibrium. That's the question. But we need to know equilibrium condition in which, in this case, price demanded equal to price supply, because we use price as a function of quantity here. Yeah? Same with this one, price as a function of quantity. So we equate, so this one, supply function, I call it equation 4. I call it equation 3. So that means we need to equate 3 equivalent to 4. So 400 over Q plus 4 equals to 1/2 Q plus 19. So call this expression 5. This is equilibrium condition. So for equilibrium condition, you don't just do maths like this, yeah. You have to show equilibrium condition. Write this one, then we know what you are doing. Because if you just leave it like this, then it is meaningless. In economics and business, mathematics here has to be explained to some extent. You cannot leave it just like that with numbers without explanation. So if you don't write equilibrium condition PD equal to PS, you just go straight to number 5 here, equation 5, then of course I would give you full mark because you are missing the main condition here. Okay. Alright, and then you can solve it. Okay, you solve it until you get, you do it yourself. You solve it until you get what? Until you get Q equivalent to 12, and then another Q equivalent to minus 54. Okay, when you solve it, you can get Q. Solve it until you get Q. You have 2 Q's to answer. That means when you have 2 Q's, it means what? In the end, after you cross multiply this, you're going to get quadratic function. Once you get quadratic function, you have to find the Q when the rest is on this side number and the right hand side is 0. Okay, so rearrange this 5 and then find Q. That's what it means. When you rearrange it, you will find that you're going to have quadratic function that leads to 2 answers here, Q equivalent to 12 and Q equivalent to minus 54. But in this case, to be logic, yeah, you need to solve it, profit. When we sell, we don't sell negative value. The minimum value that we can have when we produce or sell is 0. That means we don't produce anything. So this rules out this answer. You only need to use this to find profit. Okay, so here, to find profit, to find price. To find price, you can either substitute it back into demand function or supply function. Okay, when you substitute it back, you're gonna get price equivalent to 25. Either you substitute Q equivalent to 12 into 1 or 2, it doesn't matter because now this 12 is in the position of equilibrium. So either you choose D or S, it's just the same. Okay, then you're gonna get P equivalent to 25. So try this bit, yeah. Make sure you know how to change it to quadratic function and then find Q here. You're gonna get these 2 Q's, Q equivalent to 12, Q equivalent to minus 54. Like I said, because nobody produces and sells negative quantity, then this rules out minus 54. So you only need to use this to find price equivalent to 25. Show all the work. Here I just jump into step because for quadratic function here I expect you know how to do it because this is not something new for you. You have done quadratic function in the high school basically. Okay, alright, so that's it here for this market equilibrium. Thank you.